Hello and welcome to lecture number 45 of our course on blockchain and its applications. So, today we will continue our discussions on identity management. So, this is the third lecture in this topic on identity management and this is also the last on this topic. So, today in this lecture we are going to cover these concepts as highlighted here. First of all, the working principle of verifiable credentials. If you remember that we introduced this notion of verifiable credentials in our last lecture, where we mentioned about certain properties that it should have, and then we will see what are these different components of implementing verifiable credentials, and these different components are the different parties who are involved, including the issuer, the holder of the the verifiable credential and the verifier. So, these verifiable credentials will denote in this lecture as VCs for short, and we will see how decentralized registry can be used for VC management, the trust model. So, what are the assumptions about the trust or distrust as the way you want to see it in this verifiable credential concept. And we will see finally that we have talked about this notion of decentralized identifiers or DIDs, how they can be combined with the verifiable credentials, that is the VCs. So, these are the keywords for today's lecture: verifiable credentials of course, and then presentation of the verifiable credentials, the DIDs again we will talk about it a little bit in connection with its relationship with VCs. And finally, we will mention about Hyperledger Aries, which is a blockchain which can be used for this VC implementation. So, that is the context in which we are talking about the verifiable credentials. So, let us first take a look at the VC data model components, as we said. So, if you look at it, that we have this issuer, that is one party who is going to issue the verifiable credentials, and these verifiable credentials are issued on for certain holders. So, to give you an example, a simple example, that there is a university which is a issuer which issues a credential which can be verified. So, it is a VC for a student who has completed the course from that university. In that case, the holder will be the student who has graduated, the alumni of that university maybe, and the issuer is the university which is issuing the credential to the holder. And also in the verifiable data registry, what happens is that certain types of information would be maintained which can be used for later on checking whether indeed it was issued, the VC was issued by that maybe university, and similarly whether it was indeed issued to that particular alumni of the university. So, checking all these things will be done by means of this verifiable data registry. And then once we have this holder holding on to the verifiable credential, like the degree certificate or a transcript which was issued by the university, now say the holder wants to present it to say an employer or to another university for the next level of studies. In that case, this verifier will be that employer or that second university, and this holder will be presenting the verifiable credential that he had or she had acquired from the issuer of the verifiable credential, and now the verifier would be able to verify all the properties that we said, that this is indeed a proper and correct VC that was issued by the university to that particular alumni, and that can be done with the help of the verifiable data registry. So, we have these three entities, the issuer, holder and the verifier, and then we have the verifiable data registry which is used to ensure the security properties of this entire setup. So, what we will see is that this verifiable data registry that indeed contains the identifier. So, if you remember about the DIDs, so it is actually going to maintain those identifiers and also the schemas. So, by that what we mean? We mean that how these VCs would look like, what are its components and so on. So, those are the ones that would be maintained in the verifiable data registry. So, in the next slide we will see details of how actually the different parties would interact, so that this entire concept of verifiable credential becomes successful. So, let us look at those steps, and once again as we mentioned in the context of DIDs. So, this is also W3C standard, and it is very important that you go through this particular site and see that the details that are given there, that is basically the source of our lecture today. And also it is important that you go and see all the details about these various components beyond what we cover in this lecture, so that you will get a fairly strong idea about what these mean, why this is being developed and why it is being architected in such a manner. So, these are some of the important concepts that you need to develop, and this is a very rich source of information for the same. So, I would not only encourage, I would recommend that you please go through this particular site and get to know further details. So, let us look at the components one by one. First of all, the holder. So, holder, of course, if the holder is not there, then there is no point having a verifiable credential. So, the holder is the one who possesses one or more virtual credentials. So, I could possess virtual credentials from many different sources, as I mentioned that I could hold one VC from my university, one VC maybe from my first employer and then from the second employer and so on. So, one can hold multiple VCs, and even from the same issuer I can hold one VC that is about the degree certificate, and another is about my transcript, and then another could be about some certificate about the extracurricular activities that I did and so on. So, it can possess one or more VCs, and what is important is that this term, the verifiable presentation, means when say the next employer or the next university is asking me for my credentials, which would be verifiable, I would present something. So, which could be the entire VC that I got, or it could be a part of it. So, whatever I present to the verifier is called the verifiable presentation. Now, you see that the holders examples, as I mentioned, could be students, employees, customers and so on. The issuer is the one, the entity that asserts claims in the physical world about one or more subjects. So, then if you consider again the university example, university can assert claim about so many students, right, that this student graduated with major in this discipline and with so much of CGPA or percentage of marks and so on. So, that is the issuer which is asserting claim about one or more subjects and creating a VC from these claims and then transmitting the VC to the holder. So, the VC, as is mentioned here, is transmitted to a holder. So, example issuers once again could be university, the government and so on. What we need to keep in mind is that these VCs are issued to the holder, and then once it is issued to the holder, holder maintains that VC. So, the issuer is not going to keep a copy of that particular VC issued to a holder in the verifiable data registry. So, we should be very clear about that. The verifiable credential is not maintained in the verifiable data registry. The verifiable data registry is used only for maintaining the identifiers and the schema. So, the issuer issues the VC to the holder, but the identifier and all which will be used for validating these VC, these are maintained in the verifiable data registry. So, the subject, basically the entity about which claims are made, example of subjects include human beings, animals and things. Now, there is a slight difference between a subject and a holder. So, that is what is differentiated here. Holder of a VC might not be the subject. So, example, a parent, the holder might hold the verifiable credentials of a child. So, the subject is about whom these credentials are issued, and holder is the one who is now holding on to that credential. Or a pet owner, so is the holder, and that might be holding a verifiable credential of their pet. So, that is the subject. So, this example is given in order for you to understand that what is the difference between the holder and the subject. The verifier, as I mentioned, that verifier is the one who receives who receives this verifiable credential, okay, receives this VC as presented by the holder. And examples of verifiers, as I have already mentioned to you, are like employers and could be security personnel who would like to check our credentials before allowing access to something. So, these are some of the typical examples of verifiers. And the verifiable data registry, that is the other component, which is a non-entity component, I would say, that it is a system which is used for creation and verification of DID keys and other relevant data, such as the VC schema. Now, this VC schema is important. By VC schema, what we mean is that, say, a university is issuing a VC for its alumni about the degree certificate and the transcript. Now, how would this VC look like, the degree certificate, what are its components? So, how would anybody know? Because different universities can issue different types of certificates containing different data, different information and so on. So, it is important that we know the schema, because if you remember in our last lecture towards the end, we mentioned that these VCs should be machine readable. Now, if the verifier is using a machine to actually read it, okay, a system to read it instead of someone individually, personally, or in a manual manner trying to check the VCs, then its purpose would be lost. So, in order to be able to do that, the verifier should also know what indeed is the content of the VC, like does it have a field called roll number, does it have a field called percentage of marks, or it has a field called CGPA. So, it has to know all this. So, that together from the schema of the VC, which is stored in this verifiable data registry. Also, it will have the public keys of the issuer, of the holder and so on, which can be used to check whether indeed it was a correct issuer who was issuing that VC, and also it was actually issued to that holder who is now presenting the VC to the verifier. And also there will be some revocation details. For example, say a VC was created for driver's license and for some reason this has been revoked. So, the driver might be still holding a copy of the driver's license, and if the driver presents it somewhere, then the verifier should be able to check that this particular license, whether it is still valid or it has been revoked. So, that revocation information also would be there in this verifiable data registry. So, let us look at how things work. So, the VC data. So, say Pat is claiming to be an alumni of example university, and there could be other examples like Pat says Pat knows Sam, and Sam has the job title professor. So, you see that this example university would be the issuer for this alumni certificate for Pat, or Pat knows Sam, that could be a self certification also, which is also allowed, that Pat says that I know Sam. So, that is just maintained as a VC. So, Sam can later on say that indeed Pat knows me. And then Pat has a job title of professor. This is like the university acting as an employer for Sam, and which can provide a certificate that Sam is indeed a professor of that university. So, a claim is a statement about a subject, and here Pat and Sam, of course, as you can understand, are the subjects, and a credential is a set of one or more claims made by the entity, as we have just now mentioned. And proof is usually signature by the issuer. So, as you can very well understand that if this credential is signed by the private key of the issuer, then it can be verified using his well known public key, right. So, by that we can always ensure that indeed that VC was issued by that issuer. Similarly, if the holder is presenting the VC and if it is encrypted by his private key as a digital signature, then using the holder's public key, which will be available with the verifiable data registry, any verifier can verify indeed if it was issued to that particular holder. So, this verifiable data registry will maintain these public keys if you are using this form of digital signature using standard public key cryptography, one of those different possible techniques that we have. So, that is the role of actually verifying. We will see a bit of more details about how it is done. So, on the right hand side in this figure, you can see that verifiable credential has got credential metadata, some information about this credential itself, and claims and also some proof. So, we will see what is meant by the claim as well as the proof. So, here is this example, what is called the information graph of a basic VC. So, here what we have is that there is a credential say 1, 2, 3 and then the credential subject. So, this credential is about Pat, and what is this type of credential? This is an alumni credential, and who is issuing that? It is being issued by that example university. So, what it says? It makes the claim that Pat, as we see here in this diagram, that Pat is an alumni of the example university. So, that is the claim that is made. So, it is a form of what is called an alumni credential, and it has been issued, if you see here, by the example university. So, it is simply that something that is there in the form of a verifiable credential, and then this is what is forming the so called, you can see it here, the credential graph. Okay. So, that connections between all the different components which are the nodes and how they are related, that is forming the edges. So, that forms the credential graph. So, these two together are effectively forming the verifiable credential for Pat. So, as we see here that the first part is the credential graph, and then the second part is the proof for this graph. Now, what is that proof? So, there is this signature 456 and it says it is an RSA signature 2018, and there is a nonce which is used to ensure that this can be used only once, and then there is a signature value and it says the creator is that example university which has this public key 7. So, that means that this entire VC, it has been encoded or encrypted, I would say. So, it is encrypted by the private key of the issuer. So, that means it has been digitally signed by the issuer, and then it is something that can be verified, that is what its proof is, that is what why we use the term proof graph. So, that can be done following his signature, and then you see that here it is written that what type of signature, what type of encryption is being used, and what is the value of the public key and so on. So, if the whole thing is signed by the issuer, then it can be easily verified by using the issuer's public key which is available with the data registry. So, that is how the proof for this particular claim would work, but this is about what that has been issued, the verifiable credential that has been issued to the holder of that verifiable credential. Now, if that is the issuing of the verifiable credential to the holder, now what about presentation? So, the holder is holding on to the VC, and then say for example, Pat completed his graduation in 2021 June from example university, and then the university might have issued that VC maybe in July 2021, and maybe after 5 years Pat would like to present it to some other university for higher studies or to an employer. So, you see that these are all decoupled. So, when now Pat is presenting that VC to the second university or to a new employer, the way this subject or the holder of this VC, so which could be the subject also. So, in this example holder is the subject, that is Pat. So, Pat will create a presentation to the verifier. Now, that presentation, as I mentioned, it need not be the entire VC, it could be part of the VC, some of the components he can use for presenting to one of the verifiers. So, in that case what is done is that now Pat creates what is called the presentation graph, and then this presentation graph is having what? That it has got this presentation ABC, okay, that is the presentation which is a verifiable presentation, and then there could be certain types of other properties that are mentioned, that you cannot archive it and so on. And now, what it has is that it has this part, that is the verifiable credential, which was already there in the previous slide, that this is what he had received, and then when he is presenting, along with that the holder will present this presentation proof graph. So, what does it mean? It says that this is a proof that you see this entire dotted rectangle here. If you look at this dotted example, this example rectangle that we have drawn here. So, that is the entire presentation graph, which includes the verifiable credential and its credential proof graph. And then when this is presented, along with that the presentation proof graph also is there. So, what does it mean? It means that now for checking whether indeed this was issued to that particular holder, one can now verify it with the help of the public key of this holder. So, this whole thing has been digitally signed by the holder and it can be verified using the public key of the holder, which is also available with the verifiable data registry. And then it again says that what is the type of encryption that was used. In this example, we talk about RSA signature 2018 and then what is that signature value and nonce when it was created, and you will notice that the time that it was created by the issuer is different from the time when this particular presentation is being created by the holder to be checked by a verifier. So, as I said that this holder could actually present it maybe 5 years after he or she got it from the issuer. So, verifiable presentation, as is shown here, it has got this presentation metadata. So, data about this presentation as is shown here, the verifiable credentials of course, as again mentioned, and then the proofs that how exactly the verifier would be convinced that this was indeed issued to that particular holder. So, a verifiable presentation expresses data from one or more VCs. So, it can combine data from one or more VCs and packaged in such a way that the authorship of the data is verifiable and the holder has to convince that indeed the VC was issued to him or her. So, this is the overall flow. As we can understand that issuer would issue to the holder and then can revoke it also, and the holder can actually present it to the verifier multiple times, and the verifier can actually consult the data registry to do the verification also multiple time, and while doing the verification can check the status whether it has indeed been revoked or not. So, this only shows whatever I have described in detail in the context of the last 2 slides. So, through the diagram it is also explained here, which you can go through for understanding of the details. Now, coming to the VC trust model, means what are the assumptions about whom to trust, what to trust and so on. So, acting as issuer, holder or verifier requires neither registration nor approval by any authority. It is completely decentralized, there is no one central authority who is controlling everything, and that is the whole purpose of these types of VCs being issued and being used for this digital verification. As the trust involved is bilateral between the parties, only if the verifier trusts that this university does not issue false certificates and all, then they would be trusting this university. That is all it is. If they do not want to trust, they do not trust. No one is going to force that you have to trust this university or so on. So, the verifier trusts the issuer, as I mentioned, to issue the VC that it received. And then the VC of course is expected to either include a proof that establishes that the issuer generated the credential through the signature, or the VC has been transmitted in a way that clearly can establish that the issuer generated VC is not tampered in transit or storage. So, all these we can do through the use of this public key cryptography, as we have understood through our discussions. And all entities trust the verifiable data registry. So, this is very important that this is to be trusted, and that is what is the reason why we are discussing it in this context, that it should be tamper evident. So, that means, if it is tampered with, then it would be detectable and to be correct. So, of course, that is the crux of it, that we are talking about these VCs in this context, because as you can now understand that blockchains indeed can be of help, that it can present methodology by which whatever is entered in the data registry that can be verified by anybody, and it would be tamper evident that if there is some such changes that were made, then people would be able to detect. And holder and verifier, they trust the issuer to issue true and not false credentials about the subject and revoke them quickly when it is appropriate. So, now we come to combining the DIDs and VCs. So, we talked about DIDs, we talked about VCs. Now, of course, as you can see that there is a need to combine these two. So, step 1, as we can understand, is create and register the DID. So, both the intended holder like say Alice and the university, they would have to have their DID documents created and then they should be stored in the verifiable data registry, and we have seen that how Hyperledger ND can be used for creating such verifiable data registry. And then we have, you can see that we have did this for Alice, we have did colon registry 1 Alice, and then for the university did colon registry 1 colon university. So, they have their own DIDs that are there stored in the verifiable data registry. And then step 2 is issuing the verifiable credentials. We have seen that now when this university is now going to issue the credentials. So, Alice has to first request to prepare a transcript VC to be issued to that particular DID, which is registry 1.alice, and then university would fetch DID document that indeed that what is the details about DID registry 1 Alice, and then it will issue this transcript VC to Alice, okay, which will say that holder is did registry 1 Alice and issuer is did registry 1 university. So, what is important is that these steps would allow now after Alice made the request to the university, both the parties to verify that they are actually issuing it to the correct party and these are being issued by the correct party. Now, Alice would be getting this particular VC. And then when say there is this industry in which say Alice is making an application. So, Alice can do what? So, industry would request the transcript say verifiable presentation of the VP, and then what Alice would do is that Alice would prepare this transcript VP and it would present to the university with signature authenticating this particular did. So, whenever Alice is presenting, Alice would sign with her private key and her public key is stored. Where is it stored? It is stored against that particular did registry 1 Alice DID in the verifiable data registry, and the industry can check it against that verifiable data registry whether indeed it has correctly been signed by Alice. That is the first step, and then it would be able to fetch that information and then validate that whether the issuer of the transcript is also correct. So, in that proof graph, as we said that we have that credential proof graph where now the industry first has to check whether indeed Alice is the correct holder of that VC, and then check whether it was really issued by that particular university. So, for that also it will again consult the verifiable data registry to ensure the validity of identity by also finally checking whether this was revoked, because as we mentioned the VC is there with the holder. So, Alice is holding on to it for 4 years or so, and now Alice is presenting. So, this is not stored anywhere, it is only with Alice, but then after some time maybe there for some reason it was revoked, like the example I gave about driver's license. So, after it was issued maybe after 3 years it was revoked, but the driver is still holding on to that copy. So, anyone who is verifying will have to ensure that everything is fine, it was issued to this particular holder, it was issued by the proper issuer, but finally that it was also in between not revoked by the issuer. So, it has to consult this list of such revocations to ensure that there is no such in between revocation which invalidated that VC. Why it is required? Again, that VCs are not stored centrally anywhere and that can be directly be removed or something. So, they have been issued to the holder who is always holding on to it, and the verifier will first check everything is in place and finally consult against any list of such revocations, and that completes the full cycle as is mentioned here, that the industry now would indeed be convinced that this is a currently valid VC and it is okay to proceed with the next steps. And you can see that for DID, if you remember the DID documents, they contain those service endpoints and all. So, the industry also can then go to the next step by going to the service endpoint of Alice and do the necessary steps. So, this is all about initially validating the correctness of the VC by using the DIDs, and of course, what is important is that we have to have this verifiable data registry, which we said that from the trust model that it is very important that the second last point, that all the entities trust the verifiable data registry. The industry should be convinced that nothing is being changed in the verifiable data registry in between, and if so, then it would be evident. So, all this we discussed, and then finally, it is important to understand that why we discuss these in the context of this blockchain course. It is because there is indeed this particular blockchain which is called Hyperledger Aries, which is meant for creating, transmitting and storing verifiable digital credentials. So, this Hyperledger Aries is the one that you can click on this particular link and go to its site and get more details about it, so that you know indeed how these VCs can be actually implemented using a blockchain. Also, we will have a tutorial on Hyperledger Aries, so that you can get started with the basic concepts, but beyond what is taught in this class through this lecture or in the tutorial, it is very important that you try to work hands on by going through the sites, getting to see the examples, and there are a lot of such developers forum which you can consult, you can post your queries to them, so that you can actually master the different concepts of various such projects under Hyperledger. We talked about Fabric, we talked about Hyperledger Indy, we talked about Hyperledger Aries, and similarly we also previously talked about Bitcoin and Ethereum. So, it is important that you actually complement our these topics that are covered in the lectures and the tutorials by actually working hands on, or by going to these particular different blockchains that are available, and there is a lot of material online that you can consult. To conclude our today's lecture, we have explained the complete workflow of VCs, the VC trust model, that what are the assumptions about trust about VCs, and how we combine DIDs with VCs, and finally, we introduce this Hyperledger Aries, which can be used for actually implementing VCs. And again, the references, I mean, beyond textbooks, there are a lot of such web references as mentioned from time to time, which you need to consult, and we strongly encourage you to do that. So, that brings us to the end of today's lecture, and also this is the third and last lecture on identity management, and then we will take up a new topic in our next lecture. Thank you very much for your attention.